Good evening, sir.
Uh, how are you? So in the last class, I have just told you what how to calculate the velocity in the rotational motion. In the rotational motion, and what is the rotational motion? In rotational motion, each and every particle of the body is moving in a circular path. In rotational motion, each and every particle, okay, of the body is moving in a circular track. So in the last class, I have discussed the angular displacement in circular motion, and I have discussed the angular velocity, linear velocity, okay, and this point is important. All particles of a body performing rotational motion have same angular velocity. Suppose this white color rod is in rotation. So each and every particle of this body or rod will move with the same angular velocity. Omega will be same. Okay, suppose you can take the example of this body, and this body is rotating like this. So each and every particle of this body will move with the same angular velocity. Okay, same angular velocity, not with the same angular speed, not with the same angular speed. Okay. Hmm. So we have discussed how to calculate the linear velocity. Okay, linear velocity. In this case, you will calculate linear velocity is equal to omega into r. Linear velocity is equal to angular velocity of this body multiplied by the distance of that particle, because linear velocity of each and every particle, not each and every particle, mean different particle will be different. Okay, so this was the question. So in this question, omega is given. Omega is given t square plus 4, and they are asking theta at t is equal to 2 second and at t is equal to 0 second. Also calculate number of revolution made in 2 seconds. So basically this is a rod. This is a rod, and this rod is rotating. Okay, this is a rod and this rod is rotating like this. Angular velocity of this rod is given. Now you can see here. Here is the angular velocity. So you can see the angular velocity is a function of time. T is a time here. Okay. So omega is the angular velocity of this rod. Okay. And you have to calculate theta, means angular theta. What is theta? Theta is the angular displacement of this rod after 2 seconds. Okay. After 2 seconds, the rod is rotating like this. Means suppose the rod is initially here and it is rotating like this, and after 2 seconds, how much angle it will cover in radian, that is known as the angle, that is known as the angular displacement, and that we have to find here. So angular displacement we want to find. So what we will do, we know that for this rod, they are asking at t is equal to 2 seconds. So at t is equal to 2 seconds means you have to calculate the angular displacement, means theta, at that instant of time. Means you have to calculate the instantaneous value of angular displacement. Means you have to calculate the theta instantaneous. Okay, what is theta instantaneous? How you will calculate? Okay, we know that uh, we know that omega is equal to d theta by dt. Omega is equal to d theta by dt. Instantaneous angular velocity is equal to d theta by dt. So we can write this equation, uh, d theta is equal to omega into dt. Okay, we can write this equation omega into dt. Okay, so there is a requirement of integration to find this theta. Okay, so we will do integration on both sides. Actually, this in this question, it will be given. I think this will not be the question. At theta is equal to 2 seconds. Just a minute. Okay, so if they are asking at t is equal to 2 seconds, then omega is given. We have to change the question. Find theta in between 0 to 2 seconds. Okay, so we have to find the angular displacement, means how much will be the angular displacement in time 0 to 2 seconds. This is the question we have to find. So we can write this now. We can integrate on both sides. So I can write it as d theta, and I can write this as omega into dt. Okay. So here you will get integration of d theta will be theta, and initially if you are taking this rod initially at initial condition, what is the value of theta? Theta is 0, and here will be some theta. Okay, this is some theta. This is the final condition, and this is theta is equal to theta basically. And what is the time here? The rod is reaching here at a time of 2 seconds, and here the rod is present at t is equal to 0 at this position. Okay, basically the rod is moving from this position to this position in 2 seconds, and we have to find the what is the angle theta, or what is the angular displacement. So now we will apply the limit basically here. We will apply the limit. So from where to where? Theta is from 0 to some value of theta, and here we will apply the limit of time. Okay, in what time we want to find? From 0 to 2 seconds. Okay, so here the limit. Yes.
Integrate.
How
do you integrate?
Yeah, I am just integrating this. Earlier in all the questions, in most of the question, we have done the differentiation. Now there is a use of integration here. Okay, so I will tell you how to integrate. Actually, I think I have already told you now integration.
No, sir.
I have told you, I think. Okay, no problem. I will tell you. So basically, integration, differentiation, you know?
Yes, sir.
Okay, so there is a requirement of integration also sometimes. So suppose it is given that you have to integrate 5x with respect to x. Basically, it will be given like this: 5x dx. Basically, you want to differentiate. There is a function. Suppose y is equal to fx. Y is equal to fx means there is a function which is depending upon y. Basically, y is the dependent variable, x is the independent variable. So this function is in this form. Y is equal to, for example, this function can be in this form: 3x square plus 5x plus 2. Okay. If this y is given and uh, you want to integrate this function y with respect to x. Okay. So this is a sign of integration. Integration of y with respect to x means you will write here dx. Y multiplied by dx. So now you will put the value of y. So the value of y is this: 3x square plus 5x plus 2, and this is dx. And now you can do the integration. But now I am telling how to integrate the. Uh, Suppose it is written that you have to integrate x to the power 5 to dx. So if I want to just differentiate this x to the power 5, this is dy by dx of x to the power 5 means differentiation of x to the power 5, and this is the integration of x to the power 5. So see the difference. So here what you will do, here you will simply write 5 into x to the power 4. You will write 5 and you will just uh, decrease one power of x, and here in this case what you will do, first you will increase one power. First you will increase one power. So you will write x to the power 6, and that 6 you will write in denominator. Basically in integration, what we are in differentiation, what we are doing, basically in differentiation what we are doing, we are first increasing the power. Okay, like here first decreasing the power, here x to the power 4, and this 4 you will write here, but that will be depending upon the uh, value also. Okay, so basically this is the first thing. And if I want to just integrate x to the power 6 into dx, so what I will do, I will write x to the power 6 plus 1 divided by 6 plus 1. So it will become x to the power 7 divided by 7. Okay, if you want to differentiate x to the power 7, so how you will differentiate? So you will just write here 7 and it will become x to the power 6. So you should know the difference between the differentiation and integration. Now integration, differentiation, you know, I am removing it. Okay, suppose I want to integrate 3x square into dx. So in integration, what we do now, this number 3 is a constant number. So constant number we can take out of the integration and we can write this like this. Now we can do it easily. 3, and this will be in multiplication. So here is x square, and we are doing the integration. So what we will do, we will write it as x square plus 1 divided by 2 plus 1. So the answer will become 3 x cube divided by 3. So basically 3 and 3 will be cancelled out, so it will be x cube. Suppose 5x to the power 6 you want to integrate. So just tell me the answer of this: 5x to the power 6 dx. Integration of
5
hmm?
x to the 5 into x to the power 7 by 7.
Right. 5 you will take out of the integration because 5 is constant, and here you can write this as x to the power 6 into dx, and here you can write this is 5 and this is multiplication, and here this is x to the power 6, so you will increase one power, x to the power 6 plus 1, and you will write here 6 plus 1. So here it will become 5 x to the power 7 divided by 7. Okay. Now there can be another case also. If it is written that suppose it is written that 5 upon x to the power 6. This thing you have to integrate. Means this type of function you have to integrate. In this case, what we will do? Very simple. See, uh, this 5 is constant, so we will take 5 out of the integration. So we can write dx divided by, or we can write it as 1 upon x to the power 6 into dx. 1 upon x to the power 6 into dx. I can write now. And this 1 upon x to the power 6, I can write x to the power minus 6. Can I write or not?
Yes, sir.
We can write now. 1 upon x to the power 6 is equal to x to the power minus 6. So I can write this as 5 and integration of x to the power minus 6 into dx. Now same thing we will do. Here is minus 5, here is 5, here is 5, and now integration we will do. We will write here x to the power minus 6, and we will increase one power, and in denominator also we will write this thing. So what will be the answer? Answer will be 5 multiplied by, it will be x to the power minus 5, it will be x to the power minus 5, and here is also minus 5. Okay, so this will be the answer, and this minus and minus 5 if you want to cancel out, then it can be cancelled out. Another question. Suppose it is written that 6 divided by x to the power 36, and you have to integrate this. So how you will integrate now? You will integrate this like this. This can be written as x to the power minus 36 into dx. So you can write this as 6 multiplied by x to the power minus 36 plus 1 divided by 36 plus 1. So it is equal to 6 into, this is x to the power minus 35 divided by, sorry, it will be minus 31 plus 1. Okay, minus 36 plus 1. The term is in power, you will write in the denominator, and it will be minus 35. So what will be your answer? Minus 6 by 35 x to the power minus 35, and you can write this thing in this way, 6 by 35, and this is x to the power minus 35 can be written as in denominator, x to the power 35. Okay, just give me one answer. If it is written that 11 divided by x to the power 11 and dx, you have to find the answer. Just uh, solve this question on your copy, okay, and just tell me the final answer. Okay, so you have to follow this method, same method I have followed here. Hmm.
Is it minus 11 by 10 into x raised to 10?
Minus 11 by 10 into x raised to
10.
Plus 10 or minus 10?
On the denominator, it's plus
Okay,
10.
okay. In denominator, it's plus 10. Okay. Okay. This is 11, and here you will write multiplied by, it will become x to the power minus 11. So you will write x to the power minus 11 plus 1. Okay. Here also minus 11 plus 1. So here you can write 11. It will become x to the power minus 10. So you can write here x to the power 10, and here you can write minus 10. Your answer is right. So basically it will be minus 11 by 10 x to the power 10. Okay, so I think this is clear now. So we have to start. Okay, so now we will integrate this. Okay, this is basically d theta. Integration of d theta will be theta. And one more thing I have to tell you. There is one more thing that I have to tell you. If you have done suppose integration of x to the power 5 into dx, and there is a limit of integration also. Okay, basically this type of integration without the limit, this integration is without the limit, is known as the indefinite integration. Basically here will be some constant also. Okay, that we will discuss later, but mostly we will use the basically both type of differentiation integration we will use. So if I am applying a limit, suppose here the limit is x1 to x2. So this thing is known as the limit of the integration. So first we will do the integration. So integration will be x to the power 6 divided by 6, and limit of integration will be from x1 to x2. Okay, so 1 by 6 you can take out and you can apply the limit. How you will apply the limit? You will put x2 first. Instead of x, first you will put x2. So it will become x2 to the power 6 minus, okay, x1 to the power 6. This is known as the upper limit. This is known as this is known as the upper limit, and this is the lower limit. Okay, so it will become theta, and integration limit of integration will be 0 to theta. So here,
Can you scroll down? I want to write it. Yeah.
basically just this is a just definite integration.
Done, sir.
Write down this also. This thing is basically the lower limit, and this is the upper limit. This x1 is the lower limit, x2 is the upper limit. So here what you have to do? Upper limit minus lower limit. Okay, you will put the value in the function upper limit and then subtract it from the lower limit. Okay, so here we can write this is from 0 to 2, and what is the value of omega? Omega is t square plus 4. So omega is t square plus 4. and this is dt. Now we have to do the integration of this. Integration of t square plus 4 into dt. Okay, so we can do it, and limit of integration is given as 0 to 2. So we can write 0 to 2 t square dt plus we can write 0 to 2 4 into dt. Okay, so integration of t square will become t cube divided by 3, and limit of integration 0 to 2 plus this 4 you can take out of the integration, and here will be only dt. Integration of dt is t, and limit you will apply 0 to 2. Here you will apply the limit. So you will write, first you will write upper limit minus lower limit. So you will put the value of 2. This will become 2 cube minus 0 cube plus here you will write 2 minus 0. So what answer you will get? It will become 1 by 3. 2 cube means 8, 0 cube means 0, plus 2 minus 0 is 2. So it is basically 8 by 3 plus 2. Then now you can solve it. So it will become 14 by 3. 14 by 3. So from here you will get theta minus 0, theta minus 0, and from here you will get 14 by 3 radian per second. And what is the theta? Theta is basically 14 by 3 radian only, not per second. So understood now how to use the integration in this calculation.
Yes, sir.
Oh, okay, just a minute. Actually, we have done one mistake here. Here is 4 also, na? We have to put this 4 also. This 4 we have taken out of the integration, so we will multiply 4 also. So basically, it will become 1. Not 1, it will become 8. 4 into 2. So it will become, here you will write 8. So 32 by 8 it will become. 32 by 3 it will become. So theta will become 32 by 3. So theta is 32 by 3 radian. Have you written this?
Yes, sir.
Okay. So this is this theta. This is this theta. And after that they are saying calculate the number of revolution made in 2 seconds. Number of revolution made in 2 seconds. There are many ways to solve this problem. So I will tell you the easiest way. They are saying number of revolution this rod will made in 2 seconds. Okay. So we know that in 2 pi radian, how many revolution are there? In an angle of 2 pi, how many revolution is there?
1.
1. So if the body, or not the body, if this rod will cover an angle of 360 degree, or in radian you will say, if this body cover the angular displacement of 2 pi radian, means it will make 1 revolution. 2 pi radian means 1 revolution. Okay. In 2 pi radian, there is 1 revolution now can you tell me what will be the number of revolution in 1 radian? So in 1 radian, the number of revolution made by the rod will be 1 upon 2 pi in 1 revolution. Oh, sorry, in 1 radian, it will be 1 upon 2 pi. You can write here radian. So in 2 pi radian, 1 revolution. In 1 radian, 1 upon 2 pi revolution. So they are asking means how much radian the rod cover? 32 divided by 3. So in 30 means see here, in 1 radian, this much of revolution, this much of revolution. In 1 radian, this much of revolution. In this radian, in 32 by 3 radian, it will become 1 upon 2 pi times of 32 by 3 revolution. So number of revolution, basically number of revolution you can write made by the rod is equal to this value 32 divided by 6 pi. And there is one formula you can just write if you want to calculate the number of revolution. You can directly find number of revolution is equal to theta. You will put in radian and you will divide it by 2 pi. Directly also you can calculate number of revolution is equal to theta, means the angular displacement divided by 2 pi. So theta, what is theta? 32 by 3 and divided by 2 pi. Again you will get the same answer, 32 by 6 pi. Okay, so write down. So that is why we say without math we cannot understand physics. So you can see in this question, this is totally based on the mathematics, not on the physics.
Can you scroll?
Okay. This integration we have done here. Okay, so remove from here theta instantaneous, but basically they are asking the value of theta. Okay, they are not asking the instantaneous value. Basically, they are asking the average value. So you can just change that. Instantaneous value, to find the instantaneous value of theta, uh, basically the equation of theta should be given.
Done, sir.
Done. Okay.
Done, sir.
Okay. So now we will see what will be the acceleration in case of the circular motion, rotational motion. Okay. So this is the rod. This is the rod, and this rod is rotating with an angular velocity omega. Okay. So this rod will be first here, then here, then here. Okay. So this rod is rotating with an angular velocity of omega. So I have suppose taken the particle here. Okay. Suppose I have taken the particle here. This particle. So in rotational motion, for analyzing the rotational motion, what we will see, we will just analyze the motion of the particle. So we will see the motion of this particle. So this particle will move in a circular path like this. So the velocity of this particle will be like this. Okay. So basically the velocity of this particle of the rod, basically this is the particle of the rod, the velocity of this particle of the rod will be tangential like this. And when this rod will be here, suppose the velocity is increased, it becomes v2, but the direction will be tangential direction. Okay. Here also the particle, the velocity direction is tangential. Okay. You can choose another particle on the rod. Suppose I have choose here one another particle on the rod. So this particle will also move in a circular path. Okay. This particle will also move in a circular path like this. This particle I have chosen, and this particle of the rod is also moving in a circular path like this. This is the velocity of the particle in this direction here. When the rod will be here, the velocity will be tangential. Okay. So all the particles of rod moving in a circular path in rotational motion, and this rod is rotating with an angular velocity of omega. And I have told you angular velocity of all the particles will remain same. So angular velocity of this particle, suppose this is the particle A, this is the particle B. So angular velocity of particle A always equal to the angular velocity of particle B. Angular velocity will be same. If I want to calculate the linear velocity of the particle, linear velocity of the particle. So linear velocity of the particle is equal to, what is the linear velocity of the B is equal to r omega. So for this particle, what is r? R is this distance. R is the distance of the particle from the axis of rotation. So this is the axis of rotation. So this distance is basically given as capital R. Okay. So you can write capital R into omega, because omega is same. For particle, this is for particle B. For particle B. Now for particle A, see this particle A. This is the velocity of the particle A. This is the velocity of particle B. Okay. So the linear velocity of the particle B is given by, now this particle is moving in a circular path. So you can write B velocity of particle, this particle is equal to this distance, and this distance is given as r. It is small r into omega. Okay, so now see the motion of this particle B. So B is moving in a circular path. B particle of this rod is moving in a circular path, and you can see here the direction of the velocity is changing. Here the direction of the velocity is this, here this, here this. So basically there will be an acceleration due to the change in the direction of the velocity. What is that acceleration? There will be one acceleration due to the change in the direction of the velocity. That acceleration will be tangential acceleration. Oh, sorry, centripetal acceleration. Okay. So there will be centripetal acceleration of this particle B due to this particle. Here also for this particle there will be centripetal acceleration. Why? Because this centripetal acceleration is due to change in the direction of the velocity. Here also there will be centripetal acceleration. Suppose this speed is v. So at this point also you can say here also will be the centripetal acceleration. Okay, so we will analyze particles. So basically for this, and this particle will have some acceleration also, centripetal acceleration also, because this particle is also rotating in a circular path, and the direction of the velocity is changing, and centripetal acceleration is due to change in the direction of the velocity. So this for this particle also there will be another centripetal acceleration. Okay. Now see this particle. See this particle. Here will be the centripetal acceleration in this direction. And now if there is a change in the magnitude of this particle, change in the magnitude of the velocity of this particle. So due to that, there will be a tangential acceleration like this. There will be a tangential acceleration like this. Okay. And what is the direction of the tangential acceleration? Always tangent to the direction of velocity, or always tangent to the circle, you can say. So tangential velocity is due to change in the, if the magnitude of the velocity is changing, then there will be tangential acceleration. Okay. Centripetal acceleration will always be there. Okay, so for any rotating body, centripetal acceleration I have already told you. For any rotating body, uh, centripetal acceleration is equal to v square by r, omega square r. Tangential acceleration is this. Okay, tangential acceleration is basically rate of change of speed. Rate of change of speed is tangential acceleration. And what is the cause of the centripetal acceleration? Due to change in the direction of the particle or direction of the body, you can say. Okay. And direction of centripetal acceleration is always towards the center or towards the axis of the rotation, you can say, in this case. And direction of the tangential acceleration, tangential direction, you can see here tangential direction, tangential direction, tangential direction. And net acceleration due to this. Okay, so basically here in this direction there is tangential acceleration, in this direction there is centripetal acceleration. Due to this there will be one net acceleration. Due to this there will be one net acceleration. Suppose net acceleration is in this direction. This is the net acceleration. So net acceleration is given by this. Already we have discussed. So I have told you all the things of circular motion will be used in the rotational motion. Okay, just you can write down this, or it is better to take the screenshot. Hiba, what you should do, you should take the screenshot of this. Okay, and after that on copy, you should write it.
Sir, I already voted on copy.
You have already noted. Okay, so write down this. So remember the concept that I have told you. In a rotational motion, all the particles are moving in a circular path. That is why this topic is little bit difficult. Harsh, just wait for 2 minutes. completed this?